The fastest path isn't always a straight line. Or is it that the shortest path isn't always the fastest? Stupid. They're both right. It's whatever. Use whichever one you want, but buckle up because we're about to take a ride on an invisible interplanetary superhighway. Hello, and welcome to What the What, the show about fun facts and a little bit of science. And today, we're talking about Space SuperHighways. A recent discovery has opened up a whole new world for space travel. Previously, we only counted on the zero gravity of space, meaning since there is no gravity, objects like shuttles could just use a little bit of thrusting. Meaning since there is no gravity in space, objects like shuttles could just kind of go in a continuous path forever and never slow down. Just hit those thrusters, gain a little bit of speed, and you're off to eternity. That's scary. And that's why in space movies like Gravity, if you just kind of go off, that's it. You're going to go that direction forever until you collide with something. Gravity, like on Earth, is one of the reasons why if you're driving a car and you let off the gas, it eventually just slows down, unless of course you're going downhill and not considering engine braking. But anyway, if you're in neutral, eventually your car is going to stop. In space, you won't slow down or stop by letting off the gas. And this is great for saving fuel because you just need little short bursts instead of a constant burning of fuel. Stopping, on the other hand, takes a lot more fuel because you're working against the movement of going in the other direction, and you need more time to reach a stopping point. And understanding these limits helps us understand the distance and how long things will take for us to travel through space. We've all seen a movie where a shuttle or a satellite goes around a planet to gain momentum and kind of slingshot off into a new direction. And this is great because it saves fuel and it really can use that gravitational pull of the planet to help push the thing around. In fact, in real science, this happened when Voyager 1 and Voyager 2 did exactly this around Jupiter. Not only does it save fuel and increase speed, but it will also cut down the time that it takes for a satellite or shuttle to get to its destination, cutting it down to decades instead of potentially thousands of years. So what's the news then? Because it sounds like we've been able to kind of quickly travel through space since 1979 when Voyager 1 hit Jupiter and off to its new destination. Well, the difference is we only calculated the gravity of the planet. At the time, we didn't know that there were hidden highways throughout the solar system. That's right. We shot our satellites in pretty much a straight line and only counted on the planets we could reach for their gravitational slingshotty thing. You see, there are so many pathways that may not seem like the fastest route, but could increase our exploration in space exponentially. I finally got that line out. And this is where we talk about the whole dang point of this episode. Space SuperHighways. But before we go any further, do me a favor, leave a comment down below and let me know how you found this show. These superhighways in space are being referred to as manifolds, and they are a series of connected arches that are claimed to be the potentially fastest routes for the inner and outermost reaches of our solar system. There are various levels of strength in these manifolds, and the strongest ones seem to be near Jupiter, which makes sense because it's a pretty big old beastie boy of a planet. Typically, objects that approach Jupiter take hundreds of thousands of years to reach Neptune. But anything found in those manifolds are making their way over in just a few decades, and possibly even quicker. And as Jupiter orbits around the sun, those manifolds change with time, but they're always in sync and always recurring. For example, it's like how an airplane would fly from New York to Japan here on Earth. It will follow a jet stream so that it can save fuel and increase its speed. If you're going with the current, that is, because if you're going against it, it actually takes longer to get back. Or like swimming upstream versus swimming downstream. If you got that flow going with you, you're going to reach the destination much, much faster. You know, like in Fortnite, when the storm's approaching, you got to swim to your destination. Is going to be a lot faster, even with those S-curves, versus trying to run straight across on land. That's relevant, right? And another benefit is that we'll have a better understanding of comets and asteroids as they move throughout the solar system and potentially are a threat to Earth. And as it stands right now, this is a very new discovery, and we need a lot more data to really take advantage of these opportunities. This is actually a great example of why a quantum computer would be very beneficial for science, because it can take these calculations and find other routes or, the potential effects of what that would be on a satellite or shuttle going through these superhighways or manifolds. So hopefully in our lifetime, 10 to 15 years, we have the best quantum computers that we've ever seen, and maybe the best space travel that we've ever seen. And I, for one, love outer space, which is why I've done a few episodes on it. And I hope that within my lifetime, we find ways to travel through space at an exponential rate so that we can discover new planets and maybe find new life. And these superhighways might be one of the key ingredients to making that happen. So as always, thanks for watching, and what did you learn today?